In a previous video, we wrote a test-driven design unit test for a view model with LiveData. Just as a reminder, let's see where this fits within our application. We consume some JSON, and we use retrofit to consume that JSON, and then retrofit will create objects of a data class out of that JSON. We covered that with an integration test and an implementation in a previous video, so that's not the focus of this video. Now, retrofit will essentially work with a view model to update LiveData. And then LiveData can be observed or can be watched from several different places, including the user interface of our Android application, or in the case of a unit test, it can be observed in an Observe Forever block. We want to create a true unit test here, which means we're going to mock out the service that arranges for that retrofit call. And we're simply going to focus on the testing of this view model class here and the LiveData, which is an attribute of the view model. Now here again, we've already written the test, and this is test-driven design. So in this video, we're going to create an implementation of this view model with LiveData and then go back to our test and see if the test passes. And if so, we have a successful test-driven design. It's actually going to be fairly straightforward. In this series, the two-part video, the test-driven design, which was the previous video, and then the implementation, which is this video. The hardest part is testing an observable, because you can't predict when that observable is going to get updated. And so we handled that with countdown latch and several other things that we covered in that previous video, but we can walk through in this video in the debugger. Creating the view model is actually very straightforward. A couple of changes I made since that last video. First of all, I have a brand new branch called ViewModel LiveData so that we can stay focused on our task. And number two, I moved the test to a new class called Plant Unit Tests, and I will likely refactor Plant Test to be Plant Integration Tests so that we can have different classes for our unit test and our integration tests. Now, in that previous Plant Test video, I created the Plant Service. So when we take a look at our test-driven design, we know the first thing we want to do is make it compile. The next thing we want to do is we want to make the test pass. So to make it compile, we have to take care of our red lines. One of the red lines we can take care of right now, and that is this plant service. It wasn't created when I initially created this test, but now we do have it. So I can simply Alt-Enter and import that. And if you see under service, there's plant service, which again, created in a previous video. We see a few red lines here around main view model. So that's the next thing that we need to create. Many times we'll put that in a UI package, or we could put it out at root. Since my main activity is at root, I'm going to go ahead and create the view model there as well. So Kotlin class, we'll call this one main view model. And it's important that this extends view model. So view model is a way that we can essentially hold the state of any screen that the user is looking at or any activity that the user is looking at. And it does it in a really nice way where we can share a view model across multiple screens. So it's an efficient way to have one source of truth or one source of data that multiple activities or multiple screens look at. So we have our view model. Next, we need that LiveData type. So I'm going to say var plants. And now let's think a little bit about what we want this plants to have. If we look at plant service, we know it returns a list of plants. So we need something like a list of plants. So we'll say list plant. And if we have it like so, then that's just a normal list of plants. We need to wrap it in one more type, which is mutable LiveData. Mutable LiveData simply means this is LiveData that can be altered. It can be changed. And then when we observe it, we get that magic that we want of being able to update our user interface when the LiveData changes. So Alt-Enter to import our plant DTO or data class, which you see here, which we made in a previous video. Alt-Enter again to import mutable LiveData. And LiveData is lifecycle aware, so when an activity goes to sleep, it's no longer looking for this LiveData to update. Let's go ahead and initialize this, like so. Next, we need our plant service. I'm going to go ahead and declare that here is a variable, and I'm going to instantiate it here. I will tell you I'm going to come back and refactor this a little bit later. But first of all, let's go back to our test and let's see how we're looking. It knows where plant service is now, so we got that, and it also knows where our main view model is. So now several of our compile errors are gone in our unit test. And now we can come and focus on when country service, or actually that should be plant service, right? When plant service is invoked. A little refactoring there, but nonetheless, we're good now. So we see that we need to create this fetch plants function on our main view model. The fetch plants function does not yet exist. We could come over here and just type it. The other option is to Alt-Enter and say create member function. And notice that it's nice enough to create the function right in our main view model. I'll go ahead and move this down just so I can keep my variable declarations up at the top. Now from here, we're normally going to call our plant service fetch plants function. And you see that this is a suspend function, which means it can be suspended and resumed. And that means that it can only be called from another suspend function or from a coroutine. So we have to think about how to start our coroutine. Well, we need to start it with the scope, which determines when the coroutine will be active and when it will be inactive. And there's a special scope called ViewModel scope. And that is a ViewModel aware coroutine, which means when the ViewModel is cleared, the coroutine is simply canceled. So ViewModel scope.launch and import. Import again. And from here, we simply can call plant service.fetchPlants. And we can save this into a variable if we want. And then we need to take this list of plants, which we got back from plant service.fetchPlants. You see if I mouse over again, it's a list of plants. And we need to update our LiveData with these plants. So our LiveData, remember, is this variable here. So we say plants.postValue, which means, okay, take this and update the LiveData and let anybody observing on this LiveData know that the data have changed. And then we simply pass in inner plants. Of course, you can do that in one line if you want. I just put it on 2 lines to make it look a little bit more clear. And there we go. That's fairly straightforward. Now you see, out of the box, this class has a dependency on plant service. But remember, a unit test should only test one class at a time. Okay, so we need to mock out those dependencies. Well, if we take a look back at our unit test, we'll remember that we did indeed mock out that plant service. You see, we started by creating simply a hard-coded list of plants, and then we used mock case coevery to say, okay, when fetch plants is invoked on our mocked plant service, then return this predictable list of plants. Now the next thing we did is instantiate our view model, and we set the plant service variable to use this mock plant service. So if you take a look at our view model, what's essentially going to happen is it's going to instantiate an object out of this. It's going to instantiate the variables, including this plant service dependent object, but then our unit test is going to overwrite that with the mocked plant service that is going to return this predictable list of results. Now again, I mentioned I'm going to refactor this in just a moment to make it a little bit more efficient, or one less step, maybe a little bit more readable. I went ahead and did it the long way so that you can see what's going on. With all this, let's go ahead and take a look at our unit test and see if it runs. And we see, sure enough, the test has passed, so we have a successful test-driven design. Now the tricky part is dealing with that observer. And so I've set some breakpoints so we can watch this test run in the debugger and slow it down a little bit. So let me go ahead and debug. Now you see it's run our given, which is where it created the mock and it associated the mock with our main view model. It ran the when where it did the fetch plants, and now we're in the then part. So we start by saying, let's start with an empty array list of plants. Step over that. Now the latch is the important part. The latch is what coordinates the observer with our test. So you see we start this countdown latch with a count of 1. And then we have a latch await on line 78, which means it's going to wait for that latch to count from 1 to 0. Once it hits 0, it's going to say, okay, I've heard back from everything I need to hear back from. Or if we hit a timeout of 10 seconds, it's just going to give up. And if that happens, that means we never heard back from the observer. We never saw what changed, and in that case the tests are going to fail. That would be a not happy path. That would be if something went wrong with our test. Now let's consider this case where our test actually works. Watch as I step over each of these lines. So we start our latch. We declare our observer as an object, but notice when I hit step over, it's going to jump all the way down to line number 77, and it's going to say, okay, I'm going to observe on this observer. And then I step over. Now notice it's gone into the onChange function in that observer, which means that the observer has said, okay, I see some data that has come in and I'm observing it. So now that I've done that, I'm going to update this all plants variable to the data that has come in. And after that, I'm going to count down the latch, which means, okay, the main thread no longer has to wait on our observer because our latch is, we're saying, okay, we're going to count it down to 0. Now, while I'm here, take a look at the data that we have that's come through our observable. Notice we have eastern redbud, red oak, and white oak. And hopefully that sounds a little bit familiar because if we look at what we mocked up above, we have eastern redbud, red oak, and white oak. So 3 plants where the actual endpoint we're hitting has nearly 6,000 plants. So you see we were successful in being able to mock that endpoint. So let's proceed. Let's go ahead and say latch countdown. And then we're also going to remove ourselves as an observer so that we're no longer observing on this ViewModel's live data. I'm going to hit run to cursor, which is going to take us back to the main testing thread. Now you see back in the main testing thread, it bypassed that await where it was waiting before because the observer said, okay, I have observed the data. I've counted down the latch. Now we can proceed with our test and we can assert that all plants is indeed not null. It has 3 objects in it. And then we can assert also that all plants is not empty. Now we can go through our test where we're looking for the Cercis canadensis. And since this has only 3 plants, that's a pretty quick test. And it flips the Cercis canadensis to true. And now we proceed and we see that our test passed successfully. So there we go. We have done a successful test-driven design. Now let's do a quick refactor. You notice this mock that I did here. I'm assigning it on line number 60, and that certainly works fine for us. But there's a little trick with Kotlin I want to take advantage of. Remember that we can declare our variables up in our constructor. So what if we take this property and we declare it up in the constructor? There we go. So this is now essentially a parameter. Remember in Kotlin that with a parameter, we can give it a default value. Now this works out really well for a dependent object. We can say, by default, this is the object that the main view model relies on. But that's just by default. What if we want to actually set an object? Let's go back to our plant unit test and consider how we would do that. Now we can say, plant service equals mock plant service. And we simply pass this mock plant service in as a constructor parameter. And by doing that, it's going to use this mock plant service instead of using the default, the actual real class that we're using here. Now, oh, by the way, remember that because we have provided a default value for that parameter, if we don't specify anything, no problem. It's still going to compile. It's still going to run. It's simply going to fall back to the default plant service, the actual implementation plant service, which is what we're going to want to use almost all the time. The only time we don't want to use that is when we're doing a unit test and we're passing in mocked data. Let's look at the value of a unit test. We can run this again even after making that change, and if the test passes, we're in good shape. And sure enough, we see a green check. We see the test has indeed passed. We see build successful. And we see everything looks good. So we have a successful unit test because we see we were able to make a change and we were able to have some certainty that the test indeed does still work. So in this video, we've seen how to successfully design a test-driven design for a model view model with live data, and then create an implementation of that model view model with live data that makes the test pass. As always, I hope this video has been helpful, and I look forward to reading your comments. Thank you.